In this tutorial, you will learn how to multiply items that contain like bases. The rules are simple. First is you can only perform this shortcut if the bases are the same. If they are the same, you keep the base the same. All you would need to do is simply add the exponents together. Let's take a look at an example here. The base is x, the power is 7. We're multiplying it by the base of x and the power 4. Since the bases are the same, we keep it x. 7 plus 4 will be our new power. That is how you simplify when you multiply like bases. Take a look at this example. Base of 6 to the third, and you might remember this from a previous lesson. Any item with no power has an invisible power of 1. So this was 3 plus 1, and that's where the 4 came from. Any item with no power has an invisible power of 1. This works no matter whether your exponents are positive or negative. A to the negative 4th times a to the 6th both have bases of a, so we keep the base the same. Negative 4 plus 6 is 2. In this problem, when we perform our shortcut, which is to leave the base the same, which we did, and add our powers together, 3 plus negative 8 actually makes negative 5. Because the directions say simplify using positive exponents, if our solution does not have a positive exponent, we need to do a little bit more math. In a previous video, we learned that anytime you have a negative power, you can make that power positive by taking the reciprocal of the base. So w over 1 becomes 1 over w. The negative 5 then becomes positive. So if you get a negative exponent in your answer, don't forget that you may need to perform another mathematical rule. These are all of the examples that we just talked about. Make sure you pause the video and look them over. Now it's time for you to try 3 on your own. Simplify these questions using positive exponents. Pause the video and write your answers down. All right, let's take a look and see how you did. We have like bases, so we keep the base the same, and we add the powers. The power is positive, so I can stop. The second example, I have like bases, so I keep the base the same, but when I add my powers, I get negative 6. This one needs a little bit more work. When a power is negative, you take the reciprocal of the base, and then you make the power positive. The final answer for the second question was 1 over m to the 6th. The third question has like bases, so I keep the a the same, and when I add 7 plus negative 3, I get positive 4, so I can stop. All right, let's take a look at an example where we don't want you to leave it in exponent form. In this problem, 6 to the third times 6 to the second would be 6 to the 5th. If it actually says simplify in the directions, that means you have to perform the math 6 to the 5th power. In which case, you should be using a calculator. 6 raised to the 5th power is 7,776. Let's take a look at our next one. Remember, if you don't have a power, it's an invisible one. 4 times 4 to the negative third leaves a base of 4, but 1 plus negative 3 is negative 2. Notice that this was not circled as the response because you can't have a negative power when you're asked to simplify. So I take the reciprocal, make the power positive, and then I actually compute this math. 4 to the second power means 4 times 4. That's why the answer is 1 over 16. All right, time for you to pause the video and try these on your own. Simplify means do all of the math possible. Don't leave anything in exponent form. Pause the video now. All right, let's take a look and see how you did. 3 to the 6th power is what you would have written as your first piece of work. But then you would have picked up your calculator and you would have typed 3 raised up to the 6th power. 3 raised up to the 6th power is 729, so that's the final answer. Don't forget for the second example that there's an invisible power of 1 there. 5 to the 3rd power, using your calculator, would have been 125. 2 to the negative 3rd times 2 to the negative 2nd is 2 to the negative 5th, or 1 over 2 to the 5th power. Now the power is positive, and my final answer is 1 over 32. No decimals, please. Leave your fractions in fraction form. All right, let's try and make this a bit more complex. Let's give our bases some coefficients. Now it looks scary, but really it's just 2 problems in one. This is the same as before. The only thing we're adding is that if you have some coefficients in the front, you perform that math separately. So you notice here in my first example, I have coefficients of 4 and 3, but I have bases of x and x. So the 4 and the 3 actually have to perform that math, which is multiplying. So 4 times 3 is 12. Keep the bases the same and add the powers together. All right, so step number 1, which is new, you might need to multiply the coefficients in the front. The other 2 steps are just like before. So for this one, I have 1, 2, 3 coefficients, and those coefficients are 3, 2, and 7. 3 times 2 is 6. 6 times 7 is 42. X, 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 I keep the base the same. Now be careful. The powers are 4, negative 3, and 1. 4 minus 3 is 1, but 1 plus 1 is 2. Take a moment to look these over. All right, let's see if you can pause the video and try these on your own. All right, hopefully you paused the video. Here are the solutions. The coefficients here would be 20, the base would be w, and the new power would be 7. For the second one here, the coefficients would make a product of 6, the base would stay the same, and the new power here is negative 2. Now be careful here. Watch what happens. 6 has a power of 1, so 6 does not get flipped over. The 6 has a power of 1, so it doesn't have a negative power. So this 6 would stay the same, only the a would get flipped over. And if you have a large coefficient out here next to your fraction, you simply multiply it by the numerator. This is your final answer for number 2. Pause the video and rewatch that if you need to. For question number 3, my coefficients are negative 6, 2, and 3. That's negative 12 times 3, which is negative 36. I have variables of x to the 2nd, x to the 6th, and x to the 1st. That's 2, 8, 9. And then I have another variable of y to the 4th and y to the 5th, also 9. Number 4, 3 times 8 is 24. I have 3 s's and r to the 3rd and r to the negative 3rd, which would be r to the 0. Remember what happens if you have anything to the 0 power? That's right, it's a 1. So 24 times 1 would still be 24, so I'm going to leave that r alone. Not write it at all. S to the 1st times S to the 7th would be S to the 8th. Pause the video if you need to spend a little time looking at these questions. All right, these are a little bit more complicated. You notice I have a multiply sign here, but I don't there. So I'm going to multiply these items, and I'm going to multiply these items, but then I'm just going to put a plus sign in between them. So we've got 2 problems here, really. 2a squared times 8a to the 5th, which would be 16a to the 7th, and then 4a cubed, that's 4a to the 3rd, times 2a to the 1st, right? And that would give us 8a to the 4th. I'm going to take that plus sign, I'm just going to put it right there in the middle. These 2 items cannot be combined because their a's and their exponents don't match. All right, let's take a look at our second question here. Number 6. This is a problem that is multiplying like bases. So that's the task. This one has no multiplying in it, so there's nothing for us to do. 8 times 2 is 16. X squared times x to the first is x cubed. Y to the first and y to the first is y second. And that cannot be combined with this. They do not match. So my final answer is a sentence. 16x cubed y squared minus 3x to the fifth y cubed. That concludes our lesson on multiplying like bases.